Okay, this is the P3 paper from June 2022. It's question number 6, and if we have a look at this question, it's going to be some work on differentiation. We're going to be using the product rule there, and as we get a little bit further on down, we're going to do some work on functions and graphs and combining transformations. Okay, let's just have a read through the first bit though. It says the function f is defined by this thing here. The graph is for later on, so don't worry about the graph at the moment. Where x is greater than or equal to minus 9 over 4, can we show that f dash x works out to be equal to that? And we've got to work out what k is going to be. Yep, absolutely we can do that. So let's just make a start. Fx then is equal to 5 x squared minus 2, 4x plus 9 to the half. I want to change this into something that I can differentiate using the product rule. So basically I'm just going to times those two things together first of all. 5x squared minus 10 multiplied by 4x plus 9 to the half. And now I can set this up using the product rule. I'm going to say u is equal to 5x squared minus 10, and I'm going to say that v is equal to 4x plus 9 to the half. Differentiating those then, differentiating 5x squared is just going to give us 10x, and I'm hoping that at this stage differentiating v here is not too much of a problem to you. Treat it as though it's something to the power of a half. Right, the differential of something to the power of a half is multiply by the power, take one off the power. So it's that, but it's also the chain rule. So multiplied by the differential of what's in there, so multiplied by 4. Well, let's tidy that dv by dx up before we start trying to use the product rule. Nice and simple, it's just 2. 4x plus 9 to the minus a half. And so f dash x is going to be u dv by dx plus v du by dx. And we know now that we're going to have some messy sort of algebra to try and tidy up. So f dash x is equal to u dv by dx is those two. So I'm going to write that as, I'm going to combine them. I'm going to put the 2 at the front, then 5x squared minus 10, and then 4x plus 9 to the minus a half, plus u dv, the other two, those two there, is going to give us 10x times 4x plus 9 to the half here. Let's just go back. I'm pretty sure it's going to, well, yeah, we're going to tidy it up to look like that. So this is just going to use some algebra skills now. The first thing is to focus on this bit and turn it into a fraction here. So we're actually going to write that as being, oops, sorry, excuse me. Going to write that as being equals 2 5x squared minus 10 over 4x plus 9. If I can write 9 to the half. Leave the other one the same. Now, even if I haven't gone back to check to see what I'm trying to match up to, I would do this anyway if I was asked to simplify this. When we get to this stage, in effect, think like that and then just cross multiply to tidy up this fraction here. Would be a standard method to do, even if they hadn't said to get it to look like a particular format here. So we're going to get 1 times 2 lots of 5x squared minus 10. That bit, that's easy enough to do. And actually this bit isn't too bad either, because the whole point about this is that when I do 4x plus 9 to the half times 4x plus 9 to the half, it's going to make 4x plus 9. That's the really cool thing about this and why it's tidies up to be something quite neat here. So 10x, 4x plus 9 there. All over the bottom two times together, which is going to give us our 4x plus 9 to the half again. If you go back and, I'm not going to, but if you go back and check the what we're trying to do, it does have 4x plus 9 to the half on the bottom. So we're well on the way. Just tidying up this top. Just take your time. Don't do anything silly here where you're keen to move on. This is nice because that's only a plus there, which means that I don't have any issues with multiplying out this bracket. Sometimes that's some place to just be a little bit careful. I'll try and write while I'm talking. Always look out, try and anticipate errors before they come into your work. So we've got that, and then just whatever this is going to tidy up to on the top here. What have I got? 50x squared plus 90x minus 20 all over 4x plus 9 to the half. And then I wouldn't have spotted taking the 10 out, except I've had a look at what we're trying to get the answer to. I've been a bit slow there and not looked to see that, but you should. Should be better than me. 4x plus 9 to the half there, and I think that's actually the answer, isn't it? Yeah, so that's all done, and we've worked out then that k worked out to be equal to 10. So very good, 4 marks, not a lot of marks for some pretty complicated algebra in there, but fair enough, you know, we're at the exam level now. They have certain expectations of us. Let's go back and look at B. What does B say? B says find the values for which f-x equals 0, and even though they haven't said it, I understand that if f-x equals 0, it's going to be turning points, stationary points. We're really going to be finding those 2 points there, because this is the curve for a little bit later. We haven't done that yet, but just in advance. Find the values for which f-x equals 0, 1 mark, so just don't take any time over this at all. That was f-x. That is my answer here. Yeah, this is a standard thing that we sometimes do. If I've got the f-x equals 0, that looks horrendous, doesn't it? How am I supposed to be able to solve this equation? What's really nice about any sort of quotient question, if we do get that, is that if that equals 0, the denominator can't be 0. That can't be 0 because we'd start getting into situations where we had infinity, where we had values, undefined values there. So we can't have that. So it really means 10x squared plus 9x minus 2 equals 0, which really means, is that supposed to be a 5x squared? That is supposed to be a 5x squared. Now, I'm not going to change that, but that's a really poor mistake, Mr. Peters. I'm just going to move that over there. Move it over there, give myself time to put the 5 in there. Apologies for that. And I only noticed that. I only noticed that because I'm now going to try and actually solve this equation here. So 5x squared plus 9x minus 2 equals 0. I told you about being careful making mistakes. We all do them. And then factorising this one. If you need to know how to factorise something like this, there'll be other videos on my YouTube channel in the how-to section that will tell you how to do it. You need to be able to do it quickly, okay? Or rather, you need to be able to do it efficiently. So if you can't do that quickly in your head, which is what I try and have a go at doing, then find a method that's a little bit slower, but that you're absolutely secure on. This is one of the fundamentals to our AS level work, that we have to be able to factorise a quadratic. Now, what did the question actually ask? I'm assuming the question said, find the x values for which f-x equals 0. So, for example, this is worth 1 mark in the exam. Going back to what I was saying about, you absolutely have to be able to do that. Still practice your IGCSE techniques as we're going through. Right, I'm waffling. Let's keep going. Part C. So part C now does mention the curve. And it says for the curve, it shows a sketch. Curve has a local maximum at the point P, that one, okay, and asks us to find the exact coordinates. Well, we've already found the x values. We've already found x equals a fifth and x equals minus 2. And from looking at the graph, I can see it's the negative one. So let's just tell the examiner that I understand that. From the graph, for P, x equals minus 2. So if I do f of minus 2 now, that's going to give me the other part of the coordinate. So that's 5 lots of minus 2 squared minus 2 times 4 minus 2 plus 9 all to the power of a half. Remember the function was 5x squared minus 2 4x plus 9 to the half. Oh, doing all that. Chuck all that into the calculator and it comes out as being as being 10. So P is the point minus 2, 10. That's worth 2 marks, which is worth more marks than the factorising the quadratic. Okay, so that's part C done. And then part D now is going to be using this idea of transforming a function. It says G, this new function, is going to be 2 lots of fx plus 4. But the domain of the values is from 0 to minus 9 over 4. Now I'm suspecting that what they're actually talking about is that part of the graph. But I need to just check that that is the part of the graph from minus 9 over 4 to 0 here. So I've just got to check, is that value minus 9 over 4? If it is, then this is a nice simple graph to be able to do, but we just need to check and see what the domain for this function is going to look like. So let's do that first. This is still part D. So what I'm going to do first of all is if I say fx equals 0, what values would I get? Well, I'd get x squared, or 5 lots of x squared minus 2, 4x plus 9 to the half equals 0. Or in other words, solving that would be x squared minus 2 equals 0, or 4x plus 9 equals 0. So that's going to give me x squared equals 2. So in other words, x equals plus or minus root 2. And this is going to give me what I was hoping for, x equals minus 9 over 4. So why was I doing all that? Just remind you what I'm doing here. What I'm now saying is that that's minus 9 over 4. This is minus root 2, and this is plus root 2. But they're now saying that my function, before I start messing around with it, the range of these values, I'm going to work out the range of those values, and then I'm going to do multiply by 2 and plus 4 on, because that's what we're doing to our function. So let's work out f0 then. So f0 is going to be 5 lots of 0 squared minus 2, 4 lots of 0 plus 9 to the half. And if you plug that all in, it works out to be minus 30. Got minus 10 from that bit and 3 from that bit. So that works out to be minus 30. So now going back to the graph again, sorry I'm jumping up and down all the time. I know that this, be very careful on the graph here, it's that value there I'm talking about. That value there is minus 30. We already know that this value here is 10 from the work that we've previously done. So that's the range of fx from minus 9 over 4 to 0. I'm now going to apply this transformation to it and see what happens to the range of g. Okay, so let's just go back and explain to the examiner what I'm doing here. So we're going to say 4x from 0 to minus 9 over 4, range of fx is minus 30 to 10. For gx, which is equal to 2fx, don't need that bracket there, 2fx plus 4. If I'm now looking at the range of this one, all I need to do is to times the whole thing by 2. So I'm going to get 2 times 10 and then add the 4 on. Plus 4 is going to give me 24. And if I do 2 times minus 30 plus 4, that's going to give me minus 56. So the range of gx then is gx works out to be between minus 56 and plus 24. Let's just make that really, really clear, and then we'll finish off with this one. So what we're saying is, this is my original graph here. Get rid of all this stuff. This is my original graph here. And what happens if I do 2fx? 2fx would mean it was just stretched by a scale factor of 2 there. But then if we add 4 onto that, the whole thing would then move up by 4 units. And when we do that, that then follows that in terms of the range for this one, I can just do multiply by 2 and add 4 onto this thing and this thing. Right, I hope that all makes sense to you. That's question finished.